Hi everyone, today I'm going to be making a video regarding my solar system. So this pretty much has been in service, well I guess you can say almost fully in service for the past year, but it's taken a bit of time for me to get it all up to this state. So I'll go over the various parts of it to explain and show you how I did my solar system. So one of the first things I needed to build here was a foundation to support my solar panels, and with the size of my backyard here, decided to go and build a pergola. So I help a family member there. She's a little bit of pressure treated wood. I'm not a carpenter or construction guru in any ways, but kind of give you the overall view of what you see here. And as for the mounting hardware, so I could have bought a kit to support the solar panels, but I ended up going with, I believe it's called Unistrut, and I used that to create my mounting for all the panels. I ended up building two, I guess you could say a couple harnesses here. So the way these are arranged are in series parallel. So I got these 5 panels you see here all in parallel, and they're in series with the next row that runs down here. These are 185, 190 watt panels. There's 2 slightly different models in there, but they look identical. They're just slightly different ratings. So they'll approximately about 60 volts of output. So there's a little bit of stuff in front here, but basically those wires you see from outside come in through here, and I have them going through this breaker over here, which is rated, I believe, for, it's a C63 breaker, same breaker they use on the Adaptos. Can't remember how many amps exactly. I'd have to look up the rating, but I assume 63 amps. So that goes into my Morningstar TriStar MPPT solar controller. I believe it's a 45 amp unit. And this is programmed for a max output of around 49.88ish volts. And this charges my lithium battery that I have. So it is kind of a mess here. I'm still not 100% complete with what I want to do. But the battery's down here, so I'm using a full Chevy Volt Pack, 16 kilowatt. Alright, and they're arranged in 12S 8P, I guess you can say. So there's a total of 8 modules under there. What I did is I built a custom harness, which basically, in essence, took a lot of time to build, but parallels every single cell in every module. So you got to really know what you're doing to do that. Make sure you don't mess it up or you'll burn out the little harness that comes with the Volt Packs. They're not liquid cooled or anything. I mean, the discharge rating and the charge rating is so low for this many cells that I don't think it's much of an issue. I usually shut down the system during the winter, just obviously if there's snow on the panels, not really going to do much for me. But it depends. I'll try to run the system as far as I can go until I basically can't generate any energy here in Canada where we are. Another big thing to note is I had to make these, for anyone that's ever taken apart or seen a Chevy Volt Pack, there's these long bolts that run through the sides of them, and what they do is they hold the cells compressed, and I believe that has something to do with cooling. I would imagine is one of the first things, but also making sure they don't expand. If you guys have ever seen RC lipos over time and with cycles and stuff, they like to puff. So I'm sure there's a reason why the compression is needed. There is supposed to be a band up here as well, which I do not have. I will maybe one day put it, and I hope I don't mess up my pack because of that, but I run it pretty conservatively. So that goes all the way up here. So all those tabs you see there go into the balance port of the BMS. This is 120 volt, 120 amp, 12S, basically a LiPo BMS. So the cutoff, emergency cutoff, I think it will allow up to 4.25 volt in an overcharge situation before it cuts out the pack completely. And I think the balancing comes in around 4.22, 4.23. So it is very high. Probably not the best BMS to be using, but the chemistry in these packs is so stable that very little, very rare that you would need to balance these packs. And the solar controller is set to charge them to about 90 to 95% state of charge. So this will only ever kick in if there was a problem, and it'll prevent them from basically burning out. So the negative from the battery comes out through the BMS, which then also feeds to the negative input of the inverter. The other negative input goes to the solar controller here. So that is, in essence, is how the solar controller charges the battery, right through there. And then for the positive, for the battery bank, that connects to the solar controller, which is there. So when the solar controller is charging, I'm trying to remember how to explain this because it's been a while since I set this up. But the solar controller will basically, so it's connected right to the battery bank. So if the solar controller is charging, it'll charge directly to the battery bank. That's the main positive off the battery bank, and the negative again through through there. That's basically it. Now I do also have this inverter, which is an Ames Power Global LF Series solar inverter. This is a 12 kilowatt unit. This also has a built-in charger, and you may ask, well, how can you charge lithium using, this is inverter / charger, I should say. How could you use the onboard charger? Because the voltages are different if you really think about it. And you can see it here. Gel, AGM, seal lead acid, etc. Well, it's kind of, not really easy, but I kind of, let's just say, trick the system. So what I have here, so this is basically like a current meter, and there's a display which I have inside my home. And what this little guy does, which I'll try to show you at the end there, he can essentially, you can set on the actual menu of the controller there when to charge, when not to charge, or like high voltage, low voltage cutoff, let's just say. And there's like a switch, a relay you can hook up to it. Now, don't look at this. This is horribly hooked up. It's not on right now. I actually did not wire this correctly, and I burnt it. I actually overheated it and melted the case. I hooked it up temporarily to see if it still worked, but it doesn't work. So I haven't been using the grid power recently. Pretty much just running off the solar. This was mostly used when I had my air conditioning unit on, and if I didn't have enough electrons coming in through the day, I'd get some off the grid. But the device, essentially, you can program it so if the battery goes too low, it automatically will kick on the onboard charger from the inverter, which feeds directly to the battery. And then when the program setting of the voltage, so even though I got this programmed for 48.8.9 volts, I have the charger set to about 50.2, 0.3 or so. The reason why I have it set higher is because this thing has a beast of a charger on it. I'll just show you in here if you can see. Where is it? All right. So you can set it. It's basically got a potentiometer in there. And basically you can turn it up to like, I don't know, I don't have the specs off my head, but it's no problem. It'll push 50, 60 amps of current into the battery or even higher. I think it goes up to like, I've seen it do up to 80 or even more. I haven't pushed it all the way because, as you can probably see here, you'd think I'm crazy to push all that current through these wires. So I think I've programmed for like 40 amps or so. If you think about it, this is like 14 gauge wire. There's 8 batteries, which are all in parallel. So it's like what, 8 to 5 amps of current into each battery at once. So that's more than adequate for this 14 gauge. But it's just a pretty ingenious way. You know, I'm basically, if I would have left this inverter to do the job, it'd overcharge my batteries and so forth. For breaker, I do have this one here on there, the C125 breaker, which I believe is rated for up to 125 amps of current. Usually the last 2 numbers are the current rating from what I recall. Works fine. I would never run it that hard. Ideally, I don't like to pull more than 2.5 kilowatts out of the system, even though this thing can do up to 12. What else could I show you here? Temperature sensor is not hooked up for the solar controller. Again, this everything here was originally meant for lead acid, right? So we're using it for lithium. It does have USB programmability on this controller through the the RS232 plug. So that's there. For this little guy, in order to run the relay, he does need a power feed in, which I use. In this case, it's a 6 volt, 30 milliamp hour wall wart there, which feeds in power. This little guy has to also sense the voltage of the battery, so I have my positive hooked up there, which is this little green wire, negative that goes there, which should probably be secured a little bit better. So that gives the power reading to the monitor, and then the last 2 wires go to the relay, which can shut off the on and off the AC. I will replace this little guy shortly. Bought a new one. Definitely needs a heatsink. I should have known better. I just didn't read anything on it when I just hooked it up. I just know how they work. So yeah, so that concludes pretty much the onboard setup, or so the setup I have here in my shed. Can I add anything else? Let's see. You'll notice this is the AC feed I have coming in. So that is the onboard charger for the inverter. This is the output, which I have, I believe, is 8 gauge wire, and I'll show you where that runs. Grounded as well. Alright, so we're now inside the home. This is where I have my little meter. These are sold on AliExpress, and I'll try my best to post a link in the description of where I got this from. But basically, you can set your over voltage 49.5. It is a little low. I have to fix these settings probably, but low voltage at 40 volts. That is the inside portion there. So I'll show you how I brought the electrical into my home. So let me just bring you downstairs and show you that. Alright, so we're now in the basement section of my home. So I installed this electrical box, which has 2 sources. I didn't show you the other source on my shed, but I guess I'll explain briefly. I do have a sub panel which I installed in my shed that runs off my main panel here, which is fully loaded with stuff here. Where is she? Sub panel garage, and we got sub panel shed. So I got 40 amp service to the shed. I can't remember what that is. 8 gauge. I think it's 8 gauge. I basically did the same. I forget the name. It's tech cable. Same gauge, same rating. I went all out for the power source that comes to the house from the solar. So I'm not limited in any way. I just basically need to beef up my wiring from the inverter to the battery and all that stuff. And this should be able to take quite a bit. I've only selected to run certain loads at this time. So right now, the way I have this set up is the 20 amp here is set up to run my air conditioning. So I've had to relocate one of the wires that originally came down here. And the other set of wires, I have a wall outlet in my kitchen which feeds. It's got the 2 hots and the neutral, so each plug is capable of 1500 watts. So you want to run your toaster and your microwave off the same outlet, you can do that. So you got the 215s here. So it's got a Siemens panel there. Other than that, let's see what else I can show you. Let me just get the lights on down here. Here we go. So I have one cable that runs. So I live in a semi, and they come down here. So one of those is power, and one of those is power to my sub panel and power from my solar. And I run it all the way down here, across here, and comes into my laundry room down there, and they feed up just behind the furnace there outside. And I have them running across my fence into my shed. Everything's not 100% finished right now, but for the most part, we're going to call it 80%, 90% complete. And that's pretty much it. So I hope you guys enjoyed the tour. Probably will make another video just showing the capabilities of the inverter, what it can do. But for that to happen, as you guys know, I need to get my wiring to my inverter beefed up. But other than that, I hope this guys gives you some ideas, some little tips and tricks, and kind of keeps you on the budget of how you guys want to do your inverters, your solar system, I should say. So other than that, thanks for watching.